This is the review guide that we got before break for the final, for the semester one final. So it goes through the first 3 units, and then we'll add on to it with the 4th unit. So we're also gonna get other reviews. This is just the first review we got. This is mostly a review that you guys are gonna have to do at home. We'll have other problems and other things to do in class. So here's the video going over the answers to most of this review. We don't have the Unit 4 stuff on there yet because we haven't finished Unit 4. For each of the geometric statements below, write in words what the statement is representing and then draw a picture of the geometric statement. Okay. Hopefully you guys are much better at this than you were at the beginning of Unit 1. The first one is array. So since we have the arrow going in one direction, we know we have a ray. Okay, so this is saying ray PQ. We draw a picture. We want to have P and Q. Right, so a ray has one endpoint, and then it goes to infinity in one direction, passing through the other point. So when we label it PQ, P is our endpoint because there's no arrow on this side. The side that has the arrow over it is the side with the Q, meaning the endpoint is P and it's going to Q. So we could draw this a number of different ways. We could also draw it whichever direction we wanted, as long as the endpoint was P and it was going through Q. Okay, but what we can't do is we can't say P, Q. This is wrong. Q is not the endpoint. The name is telling us P is the endpoint, and it's going through Q forever. Okay. So we want to put something like this. P is our endpoint. Q is the side where we have the arrow going on forever. Here we have the arrow going in both directions. This means it's going through point A and B, which means it's a line. There are no endpoints. This means line AB. If we were to draw a line, we put our 2 points anywhere we want them, A and B. Remember, we need 2 points to define a line. Okay, so it doesn't matter where we put them or what order or what direction. 2 points A and B, we have a line that goes through them both ways forever. So an arrow on each side, as indicated in the name. The 2 lines that are parallel to each other represent the parallel to symbol. So this is saying L is parallel to, right? The symbol means parallel to. L is parallel to M. Let's say line L is parallel to line M. What did I write? Parallel? It's not a word. Parallel. What am I doing? Oh, man. Parallel to. And again, we need to have 2 lines, M and L. So here is M. Here is L. Okay, we can even put the little arrow representing that they are parallel to each other. They will never intersect. They will never cross. J, so this one means line J is perpendicular to line K. So perpendicular means that when they intersect, they form right angles. So if we have a line J and a line K, so K and J, they will intersect and form right angles. Okay, all four will be right angles. Okay, the next one is, that's the angle symbol. So this is saying angle, PRS. Okay. The vertex of the angle is the point that's in the middle, right? These are PR and S are 3 points. We need 3 points to define an angle. The middle point is going to be our vertex. So if we draw it out, the middle point is R, so R is our vertex. Okay, and then it doesn't matter. You can put 1 point on one side, one on the other. P on the top, S on the bottom. Could be either way, as long as R is in the middle, because R is the vertex. PRS. Okay, you could put P down here and then PRS. It's fine either way, as long as R is in the middle, because R is the vertex. R is the vertex. Can't emphasize that enough. This is a point, so this is point Z. Okay. Point Z. And how do we represent a point? We represent it with a dot. Probably not big enough for you to see. Make it a little bigger. There's a dot representing a point. And usually we would label it Z, because it's point Z. Number 2, using Using patty paper, explain how to make the following. Patty paper. Maybe I should have read this beforehand. I don't know what patty paper is, so we're just going to kind of ignore that. Using patty paper. I can't even imagine patty paper. Okay, we're not... I don't know. No idea what patty paper is. A perpendicular bisector of a... We're just going to draw them. We're just going to draw them. Yeah. Explain how to make... Oh. Okay. Well, let's draw them and explain how to make them. Using paper, just paper. I don't know. Okay. So, let's draw them first. So a perpendicular so what is a bisector? Okay, these are words we should know. We should know, well, perpendicular means 2 lines are perpendicular if, when they intersect, they form right angles. We know a bisector splits an angle or a segment in 2 equal pieces into 2 congruent pieces. We know a segment has 2 endpoints. So here's a segment, AB. It has 2 endpoints. We want to bisect this segment. So to bisect the segment, we have to split it in the middle. So let's pick the middle and call it point C. And we want a perpendicular bisector, so we need to put a line that is perpendicular, meaning that it forms right angles. So there is a line, we'll call it line L, that intersects segment AB at point C, such that it's a perpendicular bisector. It's perpendicular to AB, segment AB, and it bisects the segment, meaning it splits it into 2 congruent pieces. AC is congruent to CB. Patty paper, just trying to envision what patty paper is. How would you make it out of patty paper? I assume you would fold it in half, right? Because a bisector means we want to find the middle, because it splits into 2 congruent segments. So whatever patty paper is, we'd probably want to fold it in half. Let's just draw them. I don't know what that's saying. Let's just draw them. Okay, the angle bisector of an angle. Okay. But we know an angle bisector splits, if a segment bisector splits a segment in half, an angle bisector is going to split if a segment bisector splits the segment in two congruent pieces, the angle bisector is going to split the angle into two congruent angles. So we have an angle, doesn't matter what angle, let's call it angle A, B, C. Okay, we have angle A, B, C. If we want to bisect it, we're going to need a point in the middle, a point D, such that the ray BD makes our two angles ABD congruent to angle CBD. That would be an angle bisector. The midpoint of a segment. Okay. So if we have, again, just like in A, if we have a segment AB, the midpoint is going to be a point such that AC, it's point C such that AC is congruent to CB. Okay, the point that splits the segment into two congruent segments. Number 3, recall angle pairs. Okay, answer each question and draw a sketch of each pair of angles below. So A is asking, what is the relationship between vertical angles? Well, vertical angles are congruent, are always congruent in all situations. Okay, and then wants us to draw a pair. We need to have, in the formal definition, it had to do with two sets of opposite rays. We can just think of it as an X, two lines intersecting. And then on opposite sides, we have vertical angles. So there's one pair of vertical angles. And here is a second pair of vertical angles. So if we wanted to put angle names on these and we wanted to say, here's line AB, here's line CD, and they intersect at point E. Okay, our pairs of vertical angles are going to be angle CEA and angle BED are vertical. Okay. Then angle AED and angle CEB are vertical. Linear pairs for B. Linear pairs are supplementary, meaning that their angle measures add up to 180. Okay, so if we use, let's rewrite the diagram, but use the same diagram. Okay, this is line AB. This is line CD. Okay, we're going to say it meets in the middle at point E. We have 4 pairs of vertical angles here. So angle AED and angle DEB, these two are a linear pair. Okay. Angle DEB and angle BEC are a linear pair. Angle BEC and angle CEA are a linear pair. And angle CEA and angle AED are a linear pair. 4 linear pairs there. So the vertical angles are across from each other, and they are congruent. Okay. Then the linear pairs are supplementary. They are adjacent to each other, and their sum is 180. They form a straight line, straight angle, which is 180. Complementary angles are angles whose angle measures add up to 90 degrees. So it could be two angles, it could be more. Okay, but if their angle measures add up to, I'm sorry, what did I say? 90 degrees? I did say 90, right? Complementary angles add up to 90 degrees. So what are complementary angles? They are two or more angles whose measures add up to 90 degrees. Okay. Two or more angles whose measures add up to 90 degrees. Okay. Supplementary angles are two or more angles whose measures add up to 180 degrees. Okay. So here we have angle A, B, C, and D. Okay. Angle A, B, D. Okay. Angle A, B, D, and angle CBD are complementary. Okay. If angle, that's what I meant to do. Right. So this angle and this angle are complementary if their angle measures add up to 190. So for example, if this was 30 and this was 60, they would be complementary. If this was 62 and this was 28, they would be complementary. Okay. Supplementary angles are angles whose measures add up to 180. So I don't know if there's enough room down here, but let's erase and write it over here. Okay. So we'll say this whole thing is 180. Okay. A, B, C, and D. Okay. So since these form a straight line, angle ABC and angle DBC are supplementary. Right. This one may be 105 and this one may be 75. But if they form a straight line, they're supplementary because they're adding up to 180. The angle measure of a straight line or a straight angle is 180. That's the first page. Maybe get through, do a different video for each unit. Okay, number 4 here. Find the distance between 2 points. So we have to remember the distance formula to find distance. So we want to find the distance between points 7, 5 and 9, -1. Well, the distance formula, we remember, is going to be x2 minus x1 squared plus y2 minus y1 squared. Okay, the difference in the x values squared plus the difference in the y values squared. Well, let's look at our points. Let's make 7, 5 our first point. Can we see all the way up here? Okay, we're going to make this our x1, y1. We'll make the point 9, -1, x2, y2. Okay, again, one mistake you guys make is saying x1, x2, and y1, y2. No, the points are coordinates. The coordinates are always x, y. x1, y1, x2, y2. Don't put x1, x2 on the same point. Don't put y1, y2 for the second one. They're coordinates. They go x, y. x1, y1, and x2, y2. Okay? From there, we just substitute into our formula. So distance, okay, x2 is 9. x1 is 7 squared plus y2 is -1. Again, carry the negative. So -1 minus 5 squared. From here, you can just put this in the calculator, or we can do it by hand. 9 minus 7 is a positive 2 squared. -1 minus 5 is -6 squared. 2 squared, 2 times 2 is 4. Okay. -6 times -6 is a positive 36. Our distance is going to be the square root of 40, which is about 6.4 or so, right? 6 squared is 36. 7 squared is 49. So 40 is between 36 and 49. So maybe 6.3 or so. 6.2, 6.3, 6.4, somewhere in there. Okay, and that would be our answer. You could also put it as a decimal, but this answer is fine. All right, more length. So distance. The distance between 2 points is the same thing as the length of the segment that connects those 2 points. Okay, so I'm just going to write it up here again. So our distance formula, well, distance formula, shouldn't have erased it, is x2 minus x1 squared plus y2 minus y1 squared. Let's figure out what our 2 points are. So we want to find the length. It's not written on here. It should be the length of JK and the midpoint of JK. So J is our first point, -2, 4. K is our second point, 3, -1. So since it's -2, 4, let's just make J our first point. So that's going to be our x1, comma, y1. K will be our second point, x2, comma, y2. So x2 is going to be 3. Okay, instead of putting distance, we can say JK, right? JK, this symbol right here, JK, means the distance between J and K. That's not written on your review either. So it should be JK. So that means the distance between JK. So we can write JK here, or distance. It's fine either way. Either way, well, let's not confuse you. Let's just put D in there. We're finding the distance between J and K. So DJK. Distance between J and K. Okay. X2 is 3. X1 is -2. So minus, we're carrying the negative, a -2. Don't put 3 minus 2. It's not right. We're having 3 minus a -2. Plus y2 is -1 minus 4 squared. Okay, so our distance is going to be 3 minus a -2 is the same as 3 plus 2 squared. So we have 5 squared plus -1 minus 4 is -5. Okay, so we have 5 times 5 is 25. -5 times -5 is not -25. It is +25. So we have the square root of 50, which is going to be about 7.05 or something like that, right? 49 is 7 squared. 64 is 8 squared, so probably 7.4 2 or 1 or something like that. Okay? So the distance, the length of this segment, the distance between these 2 points is the square root of 50. Does it make sense? Does that look like it's about 7 units long? Okay. We can also look at the change in x and the change in y. Okay. So if we count how many units we've changed in the x direction, that's 1, 2, 3, 4, 5. So our change in x is 5. Our change in y is 1, 2, 3, 4, 5 as well. Okay. And this is our, again, if we know what the Pythagorean theorem is and we know about right triangles, we know 5 squared, the change in x plus the change in y is going to equal c squared. Okay. Well, that's 25 plus 25 equals c squared. That's 50 equals c squared. Square root both sides, we get square root of 50 equals c. So that's why the distance formula is the way it is. Again, x2 minus x1 is this. Y2 minus y1 is this. And then we're just using the Pythagorean theorem. But don't worry about that. As long as you can get this, you're good. Part B asks to find the midpoint. So I'm going to erase this so we can put some equations down for our midpoints. So if you remember, our midpoint is the average of the 2 points. We're trying to find the point that's exactly in between them. Okay. We know, I mean, we can figure this out without even writing a formula and trying to solve. Okay. We just said this was 5 units long. What's half of 5? 2.5. So if we go 2.5 this way, we know at x equals 0.5, right? Because if this is 3, the x value is 3, right? Halfway between 3 and -2 is going to be 0.5. We know halfway between 4 and -1 is going to be 1.5. So right there, without even doing anything, we can say, look, our answer is going to be 0.5, comma, 1.5. So I think you guys overthink midpoint, confuse yourself. If that's how you want to think of it, that's great. If not, if that's confusing and you don't understand that, we can use the formulas. The x value of the midpoint is going to equal the 2 x values added together divided by 2. We're just taking the average. We're adding the 2 x values together and dividing by, how many values are there? There are 2 values. So we divide by 2 to find the average of those 2 values. The x value of the midpoint is the average of the two. The average of the 2 x values and then the average of the 2 y values. So the y value of the midpoint is then going to be y1 plus y2 over 2. Okay. What are the 2 x values? Well, the 2 x values are -2 and 3. -2 plus 3 is 1. 1/2, which we know equals 0.5, just like we predicted. We want to take the average values of the y, the average value of the 2 y endpoints, the average of the y value of the 2 endpoints. Okay. What are the 2 y values? 4, -1. So 4 plus -1 divided by 2. 4 plus a -1 is going to be 3. So we have 3 halves, which is 1.5. Okay. Again, a midpoint is a point, which means it needs a coordinate answer. Okay. We have to put our answer as a coordinate. Okay, the x value of the midpoint and the y value of the midpoint. Well, we found the x value to be 0.5. We found the y value of the midpoint, ym, to be 1.5. These are the x values of the midpoint. These are the x values of the two endpoints. And we take the average of those two numbers to find the x value of the midpoint, because the midpoint is the average of the two. We take the two values of the two y values of the endpoints, j and k, take the average of those two y values, and get the y value of the midpoint. Put those numbers together in a coordinate, and you have the midpoint. So here is our midpoint. Or you can just look at the graph. The x changes by 5 spaces. Half of 5 is 2.5. Go over 2.5 spaces, and you're at the x value of the midpoint. You notice the change in y is 5 as well. Take half of that, which is 2.5. So you know right in the middle, we're going to have to go down 2.5 or up 2.5 to get to that middle. And when those 2 points meet, that is your midpoint. Whichever makes more sense to you, whichever method and way you are more comfortable with. Number 6. Number 6 or 5? Yeah, no, number 6. Okay. Segment addition. Okay, let's write it down. Say this is segment addition. We're adding segments together. BD is 74. So BD is the whole thing. 74 units long. BC is 2x plus 7. CD is 4x plus 1. Okay, we have to come up with an equation to solve for x and then find BC and CD. Well, segment addition, right, means we can add two segments together to get the whole length. So BC plus CD is going to give us BD. Okay. Add the first piece to the second piece, we get the whole thing. BC is 2x plus 7. CD is 4x plus 1. And BD is 74. Combine like terms. 6x plus 8 equals 74. Subtract 8 from both sides. 6x is going to equal 66. Divide both sides by 6, and x is going to be 11. Are you done? No, you are not done. The question is not asking for, well, it is saying find x, but it's then saying find BC and CD. Well, we know BC was 2x plus 7. Okay. We know x is 11, so we can substitute in 11 for x. So 2 times 11 is plus 7. 2 times 11 is 22. 22 plus 7 is going to give us 29. We also need to find CD. CD is 4x plus 1. We can also substitute our 11 in for x here. 4 times 11 plus 1. So CD is going to be 44 plus 1. CD is going to equal 45. Okay. How do we know we're right? Well, we can check our answer. We know that BC plus CD added together has to give us CD. So we know 29 plus 45 is going to have to give us 74. So if this is 29 and this is 45, what is 29 plus 45? That is going to be 14. Another 1 there. 7. 74. Check. We're good. Okay. Number 7. Angle addition. Okay, angle addition. So we just did segment addition for number 6. Number 7, we're doing angle addition. Okay. So angle AB, the measure of angle ABC is 63. So this whole angle, ABC, is going to be 63. This whole angle. Okay, ABD, the measure of angle ABD is 3x plus 2. And the measure of angle CBD is 2x plus 1. So same thing with segment addition. The two smaller angles add together to form the larger angle. So angle A, the measure of angle ABD plus the measure of angle CBD, ABD, CBD, add together to form the measure, to equal the measure of angle ABC. They wrote it as DBC, that's fine. We can write it as DBC. As long as your B is in the middle, your B is the vertex, that's fine. Angle DBC or CBD, same angle. As long as B is your vertex, we're fine. Okay. The measure of angle ABD is 3x plus 2. Measure of angle DBC is 2x plus 1. The measure of angle ABC, which they give us in the problem, is 63. Okay, from there, we combine like terms and solve for x. So 5x plus 3 is 63. Subtract 3 from both sides. 5x is going to equal 60. Divide by 5, both sides by 5, x is going to be 12. Okay, is that what the question asked for? Yes, but then it also asks for the measure of angle ABD and the main measure of angle DBC. So ABD was equal to 3x plus 2. We know x is 12. So 3 times 12 plus 2 is going to give us 36 plus 2, which is going to give us 38. So the measure of angle ABD is 38. Measure of angle DBC. That's what they're asking. Second one they're asking us for. Okay. Well, the measure of angle DBC equals 2x plus 1. Okay, so that's going to be 2 times 12 plus 1. So 24 plus 1 is 25. How do we know we're right? Well, 25 plus 38 had better equal 63, and it does. So we know we have the correct answer. Okay. Number 8. So we have some 2-column proofs based on segment addition. Okay. I would not focus too much on this for the final, unless you're strong in every other area. Let's go through them. Okay. We are given that 4 times quantity x plus 3 equals 52. We want to prove that x equals 10. So proofs, we have steps, justifications. Okay, this is given. Okay, and we're given that 4 times x plus 3 equals 52. How do we solve for x? Well, we have to use the distributive property first, or distributive property, okay, which gives us 4x plus 12 equals 52. Okay. Then we want to use the subtraction. We want to use subtraction. Okay. And that's going to give us 4x equals 40. And we want to use division. Divide both sides by 4. X is going to equal 10. Right, the subtraction property of equality and the division property of equality. The next one, same thing, steps and justifications. Okay, step 1 is given. 2 times quantity 3x plus 4 equals 56. We can use distributive property. Okay, that's going to give us 6x plus 8 equals 56. Subtraction. It's going to give us 6x equals 48. Okay, and then division is going to give us x equals 8, which is what we are trying to prove. That is by division. Right, the division, just by division, that's fine. Next two. Okay, so here, again, steps, justification. Okay, we're given that angle 1 and angle 2 are supplementary, and that the measure of angle 2 equals 145. We want to prove that the measure of angle 1 is 35 degrees. So let's write our givens. Angle 1 and angle 2 are supplementary. And we also know that the measure of angle 2 equals 145 degrees. Those are given to us. Well, what do we know about supplementary angles? We know supplementary angles, their measures add up to 180 degrees. That's the definition of supplementary angle. So by the definition of supplementary, we know that the measure of angle 1 plus the measure of angle 2 equals 145. Well, we know measure of angle 2 is, equals 180. Ooh. Supplementary angles add up to 180. And we know the measure of angle 2 is 145 degrees. So we can use substitution. Okay. So the measure of angle 1 plus 145 equals 180. And we want to prove that the measure of angle 1 is 35. So if we subtract 145 from both sides, we're going to get the measure of angle 1 equals 35. And that is by subtraction. The last one here, steps, justification. So given is our first step in every proof. So step 1, 2AB equals AC, and that is given. And we want to prove that AB is equal to BC. The distance from A to B is equal to the distance from B to C. Okay. So we can use the segment addition postulate to show that AB plus BC is equal to AC. Right? Segment addition postulate says that AB plus BC equals AC. Right? If B is a point between A and C, then AB plus BC is going to equal AC. This is our segment addition postulate. Segment addition postulate. Well, what do we know AC equals? Well, we know AC equals 2A B, 2 times AB, 2 times the distance between A and B. So we can use substitution and substitute in 2AB. So now we have AB plus BC is going to equal 2AB. Um, 4, we can subtract AB from both sides. Then we get BC equals AB. This was done by subtraction. Okay, that's fine with me. BC equals AB, we can stop there. But if we want to be very precise, we then have to use the symmetric property of equality. So symmetric property of equality. And we say that AB is equal to BC. We just switch them around the other way. And there our proof is done. So again, I wouldn't focus too much on those last couple proofs. Well, yeah, no, you should at least be able to do the first two. I wouldn't focus too much on the last two, though, but make sure you can do the two above. Okay. What are we at? 47 minutes. All right, I'm gonna stop the video there. That was the first 2 pages, or the front half, because I printed 2 on a page, and I will make the rest of it right now after this. So watch part 2 after you finish watching part 1.